Next we are going to see is about wave nature of light. Light is a transverse electromagnetic wave. So light is always considered to be a transverse and it is also an electromagnetic wave. The wave nature of light was first illustrated through experiments on interference and diffraction. So using the interference and diffraction, this wave nature was explained. Like all the electromagnetic waves, light can also travel through vacuum. The transverse nature of light is demonstrated in polarization. So this wave nature is explained in interference and diffraction, and the transverse nature is explained in the polarization. Clear? So next is we are going to see about what is wave optics. Wave optics deals with the wave characteristics of the light. So how the light is in the form of wave. Okay. With the help of wave optics, we are going to learn in details the phenomenon of interference, diffraction, and also polarization. Even the laws of reflection and refraction are proved only with the help of this wave optics. Okay. Though the light propagates as a wave, its direction is still represented as a ray. So direction is represented as a ray, but the light will propagate as a wave. Okay. And how it is? Let us see now. Let us consider a still water. Okay, so when the water is still and suppose you throw any stone in this still water, what happens is it forms a wave like this, is it not? So from the center it moves on as a wave. Okay, and that says you that an example for the wave propagation is the spreading of circular ripples on the surface of still water. So from the surface of still water, it forms with the circular ripples, okay? At which the one stone is dropped, okay? From at what point the stone is dropped, from that point it forms the ripples. And the molecules or the particles of water are moving only up and down. So molecules, what it does, it moves up and down. When the ripple passes out that part, okay, and all these particles on the circular ripples are in the same phase of vibration and they have the same distance from the center. Okay, so it will have the same phase and also it has the same distance from the center. Okay, and the wavefront is the locus of the points which are in the same state and in the same phase. Okay, same state same phase of vibration then that is said to be the wavefront. Okay, then, when a wave propagates, it is treated as a propagation of wavefront. Okay, so when any wave is propagating, it is moving, it is considered to be the wavefront. So, what is a wavefront? Is so these are all the waves which are formed for that disturbance, is it not? So each one forms a wavefront. Okay, so the wavefront is always perpendicular to the direction of propagation of the wave. Suppose if this is the direction of propagation of the wave and this will be the wavefront. Okay, as the direction of ray is in the direction of propagation, the wavefront is also perpendicular. So wavefront will always be perpendicular to the rays. Okay, and the shape of the wavefront is observed as a point and it depends on the shape of the source and also the distance of the source. Okay, so how the source is, so the shape of the source and also how the distance is, how much is the distance. Okay, so that depends on the shape of the wavefront. Okay, then a point source which is located at a that is at a finite distance, it gives a spherical wavefront. So when you consider this to be a point source and this is at a finite distance, okay, and that will give a spherical wavefront. And the next is the source which is at a finite distance and it gives a cylindrical wavefront. This is a point source and this is a line source. Okay, so line source which is at a finite distance, that gives a cylindrical wavefronts. Okay, and the wavefronts are received from any source located at even infinity. From the infinity also we can get with the wavefronts. Okay, so here we have the different types of sources. Okay, so this is a point source and this is a line source. From the point source we get what? Spherical wavefront. From line source we get it as cylindrical wavefront. Okay, and these are all the sources from infinity. Even from infinity we get with the wavefronts. Clear? Thank you.